So for this session, we are really starting a new journey. And for this session, I'm going to entertain you guys on how to export data from R. And we're going to learn how to export a data frame. You can create or generate a data frame on R and even tables and be able to export it in Excel format, in CSV format, and even in HTML. So I am called, for those who don't know me, I'm called Pascal Koh, a data analyst of PyToka. That's a team of data scientists. And I'm also the coordinator of the R Club at the University of China. So we continue, and what are we going to cover? As I said, we'll learn how to generate a data frame in RStudio and do some summary statistic that we are going to export as CSV output and also as Excel outputs, and also in HTML format. So that's what we are going to cover. Then, just a minute, we're going to use some libraries in R, some packages. And these packages are altogether 4 of them. You have the dplyr, the readr, and the open xlsx, then flex table. Then some functions that we are going to use from this package. We have the group by function, the summarize function, the write.csv, the write.excel, we pronounce it this way, and the flex table. So the function group by and summarize will come from dplyr. Then the function write.csv from readr, which is going to help to export in CSV format. Then write.xlsx is a function from OpenXLs, which is going to help to write our data in Excel format. Then the flex table will help to come up with beautiful tables already ready for publications. I hope everybody can understand English, and I can always tutor from English and French. If everybody is comfortable with English, I will continue with it. Maybe they are not comfortable, please just indicate to me. So we are going to practice it now. I'm going to share my RStudio. Okay. The RStudio is shared and everybody can see it. So the topic, when you open your RStudio, the first thing is to clean your environment. You clean the memory here. You should clean, there's a brush here. So when you click on it, you click on yes. It helps you to clean all the objects in your R memory. The R memory is just like the brain of R. And you need to clean the objects so that the computation is done a little bit faster. Then you can also clean all the commands history from here. So click here, clean everything. You can also clean your console using your keyboard, Control L. Control L, it helps you to clean the keyboard rapidly. That's the first thing when you open your RStudio. And your script must be neat. As you can see, this instruction script, you have the topic here. You have the topic, generating and exporting data frames and table. You usually use a hashtag to tell R not to consider those lines of text. If you don't do like that, R will think that's a function and will generate errors at the console. So you should use hashtags. Those are a kind of remarks or any commentary or any anything that you want to say without it necessarily being a function or a line command. You can do it like that using hashtag here. The next thing, you load the required packages. So we are going to load the dplyr package. How do you load it? You load it by clicking on run here, or you can click on control enter. Control enter. That's the first package we are loading. Then the next one is open Excel. Load it. Then we load read R. And finally, flex table. So after loading these packages, because these packages have some functions that we are going to use, so it's necessary to load them. The next thing now, hello, can everybody get me?
It's fine for me.
Okay, great. Now, the next thing is to generate a data frame. So we are going to generate our own data frame. We don't have any data yet. We are going to simulate an artificial data. We are not. That's not our topic of today. To import data from other sources, that is from your hard drive, from remote areas like the internet. So that's not what we are doing today. I just want to generate some data so that it helps us to see, to understand how you can import it. So how do you generate? The first thing is to create 4 vectors. So I've just thought of some vectors like plant, season, habitat, and then what again? Height. So I just thought you could have plants and you are measuring their height based on the season and the habitat again. So you have a kind of height, which is a numeric variable that I want to generate. Plants, types of plants, categorical variable with different classes. Then you have season, dried and wet. Then you have habitat, which is also a categorical variable. I didn't spell it very well, habitat. Okay. Now the first vector is season. So we create a vector known as season, and it's very easy. This is how you create a vector in R. You write the name of the object, that's season. Or let us start with height. Height. I want to create a numeric variable since height is numeric. We can do some random sampling by using the function sample. So we want to generate a random sample of numbers. Let's say we generate numbers from, say, from 10 to, let's say from 10 to 40. From 10 to 40, random numbers from 10 to 40. And we are going to pick up, let's say 32 out of this random number that we are generating. We're going to pick just 32 of them, since we are going to create a vector of length 32. And it should be a random sampling, let's say with the replace equals true. So I execute the command, and R is going to pick up from those numbers, that is from 30, from 10 to 40, 32 numbers, and it's picking with replacement. So after picking one number, it's going to put back the number, and that number can still be picked up again the second time. It's possible. So if you look at the environment here, you see that it has been generated 1 to 32 here on your top right. And we can even see those numbers in the console by simply typing height and executing the command with Control Enter, or you can click on run here. So if you click on run here, you see those numbers that have been generated here. And those numbers are within 10 and 40. So we have created the first variable of length 32, that the sample size is 32. Now, we want to create categorical variable plant. So we write the name of the object plant, and use the assignment operator. So this is the assignment operator here. This is the assignment operator. And now we're going to use a special function of repeat, which is used to create vectors. So let us assume that there are 4 plants, and let's name them A. Plan A, plan A, plan B, plan C. Let's put like this: plan B, C, and then plan D. So we have 4 plants, and now we are going to concatenate it with the function C. So we concatenate it, and then we are going to repeat each of the plants. So we are going to repeat each of the observations, the plants. Let's say if you say 5 times, that would be 5 times 4, which is 20. If we say 8 times 4 is, or let's say 3 times. 3 times 4 is 12. And we need 32. So let's say you take 6 times 4, 24. Let us take 3 times. Oh, it's going to disturb a bit. I will suggest that we change it and take A. Now we're going to repeat A, let's say 10 times. Repeat B. We're just giving numbers. Let's say B, let's say plus 10 is 22. Then let's see, it'll be much, let's say 5 times. That's already 15. Let's repeat C 10 times. That's 10 times, that's already 25. And the next one will
please,
be...
Pascal.
Yes.
Please, Pascal.
Yes.
Can
hello?
you yes, there is other student who want to enter the courses, but it's not possible.
Oh, okay. I see. Yeah. Okay. Thank you for reminding. I missed it. I'm letting them in now. Okay, just wait a while.
The answer.
I want to think they may be having. Okay, good. It's remaining 1 person. Okay, they are all there. Great. So I'll just repeat this line command 27 again. So I'm creating a vector plant, and with 4 classes: plan A, plan B, plan C, plan D. And we are repeating plan A how many times? 10 times. Plan B 5 times. Plan C 10 times. Plan D 8 times, in order to have a sample size of 32. Because normally when you want to get a data frame, all the columns must be of the same size. The columns are those vectors that we are creating. Actually, those vectors that we have created. So let me run this line command here. Okay, I'm running it. Yeah. As you can see here, it's 33. So you can reduce 1. Let's say from here. Let us put 9. Let us run it again. It's done. You can see here in the R environment, that is 1 to 32. And it's possible to see what is found in plant. It's possible to see what is found in plant by just running plan alone. Control, you put a cursor in front of plan and you type and you click on Control Enter. It will display the results at the console here. You can see those values, those categorical, those classes, and it's altogether 32. So it's also of the same length like height. So in this case, we have created already 2 vectors. We need now the third one, that is season. So write season. We use assignment operator. We use the function repeat too, and we have 2 seasons. Let's say wet, and we have dry. And in this case, you should separate them with comma. And since they are character string, you should always put them in quotes. That's why I'm putting them in quotes here. You concatenate it with the C function. And the next thing, you should set the number of times you are going to repeat each of them. Let's just assume that you repeat wait. Say the wait season is usually longer, so let's say 20 times. Then we are going to repeat dry season how many times? 32 minus 20 is 12, so 12 times. We close the bracket and we run the line code with Control Enter, or you can click on run here. So after running, it's going to be displayed at the console. How do you display at the console? You copy season, click here, paste it here, and then Control Enter. You have the vector generated here. The last one is habitat. So we are going to generate a vector of habitat. Let's say write habitat. Assignment operator. Then you do the same thing. Repeat. See. Let us assume some habitat. Let's say habitat 1, habitat 2, habitat 3. Let us end at habitat 3. And you should put them in quotes so that R can treat them. If you don't put them in quotes, R is going to tell that there's an error. It doesn't understand that language. So after doing it, let me check. It's like there are some more people coming up. Yeah, this one coming up. Let me let him in. Okay. So we continue here at line 35. So we can repeat each of them. Or another way of doing it, let us do the same way. Let us do the same thing. So let us say habitat 1, we are going to repeat it 10 times. So we write 10. Habitat 2, we are going to repeat, say, 9 times. Then habitat 3 will be, when we have 10 plus 9, that's 19. 39 minus 19 will be how many? Will be 13, I think so. So let's run. And let us execute habitat. So when you run habitat, you are going to get the result at the console here. And it also has a length of 32. Even in the environment, you see all the vectors is from 1 to 32. It means it's okay for us now to generate our data frame, to bind the 4 vectors together to form a data frame, and it's easy. Just in one line code, we can obtain it. So let's give the name of our data, or the name of the object, data, and we type the assignment operator, and we should use the function data frame. There are other functions that can be used to generate, like data underscore frame from dplyr. I don't want us to go to it for now. And then you write the names of all the vectors that you had up. You have height, plant. After plant, you have the season. Then lastly, you have habitat. Lastly, you have habitat. Now, you can run this line code, that's line 40. Obtain our data frame. So I'm running it. Now, how do we see the data frame? You run data. Since the name of our object is data, if you look at the R environment here, you see that data contains what? 32 observation. 32 observation means 32 lines and 4 columns. That's 4 variables. So if you want to really generate it at your console, you run the object. And then you can see here at your console, your data frame already generated with all those variables. If you like to view it in a more appropriate way, you can use the function view, and then you type the name of the object, and it's going to appear here at the script environment here. So this way you have the script or the source. We also call it the source. Let's see, it's not yet appearing. Let's see. It's taking some time. Okay, that's it coming up here. And so after generating the data frame, we are going to continue with how to export them. So you can see that data frame here. Is it here? We go back to our script here. And the next task is to write, by saying here, the next task is to write the data in Excel format. That is to export it into our hard drive in Excel format. It's possible. We have already loaded the package Open Excel, which will help to export our data frame into our Excel format in our hard drive. So the function that is needed is simple. So just write dot Excel, then in bracket, you write the name of your data. It is data. The name of the data is data. And the next thing is to write the directory, to type the directory. And the directory is simply where you are going to store your data. Yeah, where are you going to store the data? That is your directory, where to store the data. And we can now go to our hard drive, get the address where you are going to store the data. Okay, so how do you do it? Let me open my hard drive anywhere. I'm going to show the screen soon. I'm going to show the screen. Let's say I'm going to save here. Just a minute, you guys will not see it because I've not yet shared the screen. I'm creating a folder there where I'm going to store the data. I will call that folder R club, let's say R club 1. Okay. Now, let me share the screen. Let me share the new screen for you guys to see it. Just a minute. Okay. Want to share the new screen. Okay, you can now see my hard drive here. So after you get the directory here, you click here, and then you copy all this. You copy. Let me see. I want to save it in here. So in this folder R club, so I will go and copy the directory like this. I copy, then I go back to my R Studio. Let me reshare the screen of my R Studio. Okay, you can see the screen now. So I'll paste it here. That's the directory. But I need to change this slash into backward slash. So I change all of this into backward slash. So that is my directory. Then I have to give the name of my data. The name that I'm going to give to my data, I can still call it data, or let's say, I don't know, data2. I type the extension, data2 dot, the extension in Excel format. So that's why I type the extension. So the line command 52 gives you now the code to be able to export it in Excel format. So I'm going to run the code line. So I run it. R is computing. You can see here, when you see this red mark here, you have to wait. It shows that R is working out, and sometimes it's delayed because the memory is saturated, or sometimes you may be downloading certain, or you are some of the softwares may be updating, so it delays. So it's okay. We can see it here. If you go into a hard drive, let me go to the hard drive now so that you see the data that has been exported into the hard drive. It's the hard drive. Okay, that's the data that has been exported. And let's see. There's someone coming in again. Yeah, it's okay. So this is the data, and I can even open it. You guys are going to see it. So that's how you export data. Let me go back to why it is opening up. Let me go into our studio. As soon as it's open, I'm going to show the Excel data. So this is how you export the data in Excel. You can also export it in CSV. You can just simply copy the same line command, but you change the extension here into CSV. Here, the same thing into CSV. Okay. The data has been opened up. I will show the screen so that you see the data frame in Excel format. So this is it. This is the data that we have exported into our hard drive. Can everybody see it?
Yeah.
Okay.
Yeah.
Yeah. So that's how you export the data into a hard drive. Now we are going back into R Studio. I share the screen. So I was saying that you can also export it in CSV. So you simply change the extension here into CSV, and you run the command. I will change the name of the data tree so that it should not be mismatched with the other data already there. So that's how you export it also in CSV. And if you go into a hard drive, we are going to see it. Let me share the screen of my hard drive so that you see in CSV. Okay, this is it in CSV, and I can also open it. Okay, I'm opening up. While it's opening, okay, this is it. This is in CSV. And you see that in CSV, the values are comma separated. They are comma separated. Unlike in Excel format, so the values are separated by commas instead. Let's go back to RStudio and do the next task. The next task is to come up with the summary statistics and form a table. You can create a table and export it. That is, we create a table and we are able to export it in HTML format. That is already a format that you can easily share with other researchers. You can even publish it immediately. If you don't want anything to be changed in your data, you can export it in that format and share to people. So it's possible. We are going to use two functions from dplyr. The first thing is to write the name of the data, which is data. And we use the pipe in operator. This is what you call the piping operator. How do you type the piping operator? It's simply Control-Shift-M. Then you go at line 58, and then you write the function group by, which is a function from dplyr, and we're going to group it. Let's say we're just choosing anyhow. Our data, this is our data here, is having a numeric variable height. This is the height. Let me bring it a bit up so that you guys can see it better. Bring it up. Okay, and bring it up. So that's a numeric variable. The others are categorical variable. So we can calculate some summary statistics for each classes of the categorical variable. That is, for instance, plan A, we can calculate the mean height of plan A, the mean height of plan B. The same thing with season, the mean height of plan in wet season, and so on, for different classes. That's what we are trying to do. And we can calculate other statistics like standard deviation, like range, and so on. So we use the function group by. Let's say we want to group by, let's say by plant. We do two groupings, by plant and also by season. It's more, this is a bit complicated now, but there's no problem. And we pipe in again, we go at the margin, and then we use the function summarize, still from dplyr. Function summarize dplyr, and in bracket we are going to type in those statistics that we want to obtain from them. So we want to obtain what? The mean for instance, and the name of that mean, that variable will be still mean. So that's the function mean, which shall be calculated and given the name mean. Then in bracket, we write what we are going to calculate the mean. That's the height. We're going to calculate the means of the height. If they are NRs, they are missing values. If they are missing values, but unfortunately we don't have missing values, you should add this argument in NR. What am I writing? Okay, NR remove true. But since there's no missing value, no need to add this argument. So if we end here, we are going to obtain the mean. Let's say we want again the standard deviation, SD, for standard deviation, and the function to calculate standard deviation is small s, small d. In bracket, write height. Let's say we want to calculate the sum. We want to sum the values. Let's say we want to sum the values, for instance. We are going to write sum, and then the function to calculate the sum is state sum. Then you have the height. You can get other statistics like median. Let's say we want the median. Write median. Since the function is long, it's possible to cut it at some stage. So we cut it at the margin. So we are calculating the median in bracket height. So that's the code. You run it. You have the result here. You want to make it neat. I want it to be viewed at your source. So if I want to make it, if I want to view it at the source, I should store it in an object, for instance. So to store it in an object, you can either put the assignment function at the end or at the beginning. So I'm going to put it at the end. And it's quite easy. when you are putting it at the end, you need to reverse the assignment operator. Reverse it. Let us store it in an object called df. I run down the command, and it is already in df. The object is going to be created somewhere here at the environment here soon. This df here created, and now we can view it. It's like the session is going to go off, so I would suggest as soon as it's off, you click on the same link so that we end it if I'm not able to finish it in time here. So when I run it, you'll find the results here at the source here. It's going to appear here at the source. I've executed already the command. There's some delay. Okay. There's some delay. Some delay. Okay.